All right, hello people. Hope you had a great spring break. First day back here. We've got this simulation that you guys can use while I'm taking this video, just FYI. We got little dude laying down there. And then over that way is Hayden and Mrs. McSparron. They're doing their fingernails right now. All right, so you guys have this simulation you can use today. So here it is right there is a simulation right on Canvas. Now it's embedded on Canvas, so you can use it right here on Canvas. I am going to go ahead and make it full screen. You can do that as well. Oh, no, I'm not going to make it full screen because I'll leave it on full screen even though you can't see me. All right, so we've got the intro. Did you guys see that? What I want here is the intro, not vectors, not drag, not lab, intro. Okay, so there's a handful of things you can play with here. So there's a cannon. The cannon goes up and down, so you can move it down. Notice you've got the number of meters, 9, 10, 11. You can put it whatever meter setting you want. You can angle the cannon, but I want you to leave it at 0, okay? We do not know enough trigonometry to be able to do calculations with the angles, so leave the angle at 0 and the math will be nice and easy. You can also change what type of object gets shot. So right now it's going to shoot a pumpkin, but I think it's more fun to shoot bigger things like a human. Like I can shoot a human. By the way, the little red button shoots the cannon. The yellow button erases the shot. I can even shoot a car if I want to. I can shoot the car. Okay, so it traces the path that it went down, and then it lands a certain distance away. All of this simulation is set up to imitate the world and the gravity of the Earth. Notice you can turn air resistance on or off. Leave air resistance off. We don't want to check that. Don't worry about checking any of these either. We don't need to see that stuff. Now I can change the speed. So that car got shot at 15 meters per second, but I can slow it down to like 10 meters per second, and it's probably not going to go as far. Oh, look, I hit the target. You can move the target around too. We'll deal with the target later on. I can make it go 5 meters per second, and it's not going to go as far. Oh, it landed on that guy. That sucks. Okay, now here's the really important thing for you is this tool right here. You pull that out, and it says time, range, height. See all these little dots along the pathways? If I hover this bullseye over the top of any dot, it will give me the information for that dot. All right, so when the car was at that spot, it had gone 0.5 seconds. It had gone 7.5. Range means the distance from here. So like if you went like from here to there, that would be 7.5 meters. The height was 8.77. So it started at 10. It's gone down to 8.77. And you'll see the time gets a little bigger, the range gets a little bigger, the height gets a little smaller. Time bigger, range bigger, height smaller. Okay, so as it goes down, it goes a little farther, and a little farther, and a little farther. And eventually you can see here at the very end, that car took exactly 1.43 seconds to hit the ground after it was fired. It traveled 21.42 meters, and now it's at 0 because now it's on the ground, so 0 meters on the ground. So you guys can run some different trials to try and answer that question. Do objects fall faster if they're going fast to start with or if they're going slow to start with? You can set it up. You can use your little tool here. Make sure that we're writing down any evidence that we have so you can give an explanation later on. If you have questions, ask me.